All right, good afternoon, everybody. Let's jump right into this. I will not be using my webcam today because I think that is messing up my audio. So I'm just going to be speaking to you like this. So sorry you don't get to see my wonderful face. All right, so we're on lesson 3 of topic 8, the effects of changing climate. All right, starts on page 406. All right. I'm going to be jumping right over to page 408 to get right into the content here. All right, so we're on page, can you see it? Yes, I can see it. Thank you. All right, so we are on page 408, and the first thing we're talking about here are rising sea levels. So the effects of a changing climate. One effect could be rising sea levels. How this all works, we know as global warming continues to warm the planet, what happens to ice is it warms. It melts. So we have our polar ice caps, right? North Pole, South Pole. We have the Arctic up north and Antarctica at the South Pole, and they're covered in ice. As the Earth increases in temperature, that ice is going to melt. And when ice melts, it turns into water, and that water has to go somewhere. So just like if you're filling up a glass with water, eventually, you keep filling it, the water level is going to rise to the point where it spills over. Well, eventually that water is going to spill over, right? So we start seeing water estimated to rise over the land, right? So here's the continental United States, right, rising up over the land on the eastern seaboard right here. This would probably also happen on the west coast as well. So if you look here at New Orleans, for instance, is currently actually underneath the level of the ocean, right? So it's actually lower than the water level. However, it's not covered in water because they built these things called levees, which are basically these walls that go around the area and kind of like dam off the water, right? So just like a water dam would work, it stops the water from continuing to flow, right? So they estimate by the year 2100, right? So that's 80 years from now. They predict that New Orleans is going to be submersed underwater, right? It's going to be covered with water. If we look over here, city of Miami, all right? So not exactly sure where that falls here. Let me see if I can see that here. So if we look, maybe not quite in the next 80 years, but at least within the next 600 years, Miami will also be underwater. Okay. Now I'm gonna send you over to a quick video explaining this a little more. I got a bunch of videos for the different things we're gonna be talking about today. They're not too long. Each of them are only a few minutes. So sit back, enjoy, take notes. You might want to pause the pages on certain things you want to take notes on, like right here. Why is a city like New Orleans especially vulnerable to rising sea levels? Right? So much of New Orleans is already under the sea level, which is what I said. So rising sea levels might most likely affect it by going over those levees, right? So submerging the city itself. All right, so here's a quick video on rising sea levels.
Sea levels are rising across the globe. According to scientists, the levels have accelerated more than ever in the last 2 decades, and it's the fastest rate of increase on record. So what causes sea levels to rise? Climate change has a role to play in this. If the global temperature goes up too much, it causes the oceans to warm up and sea waters to expand. This takes up more space in the ocean basin and causes a rise in sea level. The warm water causes glaciers and ice caps to melt, adding to the rise in sea levels. This is happening in the Arctic and Antarctic. The increased heat is also causing the massive ice sheets that cover Greenland and Antarctica to melt at a much quicker pace. This has an impact on low-lying coastal areas and can cause islands to gradually disappear. So when did rising sea levels begin? Scientists say that until 150 years ago, Sea levels had been stable for 6,000 years, but over the past century, sea levels have risen by 20 centimetres, and the rate at which it happens is speeding up. Some of the islands around Africa are at risk of disappearing if this trend continues. For example, let's take a look at Mauritius, situated in the Indian Ocean and not far.
I would also assume that this might also apply to any of the islands that you would find elsewhere in the world, like for instance in the Caribbean Sea.
From Madagascar, it's a country which consists of 20 small islands and is surrounded by coral reefs. According to Mauritian officials, sea levels around the coast are increasing at an average rate of 5.6 millimetres per year. This will cause beaches to erode and affect the tourism industry, a sector which the country heavily relies on. And around 26 kilometres of beaches could disappear completely.
Alright, I'm back. I've moved on to page 410, and here we're going to be talking a little bit about the Cascade Effect. Okay, so we understand what global warming is. We understand that it can impact rising sea levels, but some things have more effects than we can see at first glance. Okay, some disturbances might be caused in different areas of the world when we didn't expect them to. All right, so something that causes something that causes something else, kind of a domino effect. Okay, so if we look over on the right-hand side, okay, so over here we're going over 3 different possible cascade effects, right, of global warming. Now the first one we're going to talk about here, all right, disruptions in participation patterns cause heat waves and droughts. Okay, so a drought meaning, right, very little rainfall, very little moisture in the area can cause plants to die, can cause animals and people to have to move to different areas. Okay, now I have a video on each one of these. At some point, please make sure I'm discussing them with you as we go. But if you want to pause the video and get your notes down for each one of these, please feel free to do so. That's only going to benefit you later. All right, so here we go. First video on droughts.
Drought is a defining feature of Australia. Its impacts can be distressing and affect the whole community. But not all droughts are the same. They can vary in the size of the area affected, the intensity, and how long they last. So what do we mean by drought? There are several types of drought. Meteorological drought relates directly to less rain than usual. Australia's rainfall is highly variable. When somewhere receives less rain than usual, we say it has a rainfall deficiency. If there is much less rain than usual, we might talk of serious or even severe rainfall deficiencies. Continued low rainfall can mean less runoff and lead to hydrological drought, especially when combined with high temperatures. River levels fall, water storages drop, and soils become drier. This lack of water can go on to affect people and their livelihoods. Agricultural drought means reduced productivity, lost income, and a strain on those communities. Socioeconomic drought sees effects spreading through the wider community. In fact, our whole environment is vulnerable during drought. It's not easy to say when a drought is over, or even how much rainfall is needed. There may be enough rain at the right time of year to grow a crop, but not enough to replenish water storages. In some cases, it could take many wet months for the landscape, waterways, and communities to recover. Once the environment and the community have enough water to meet their needs, we can consider the drought to be over. And with Australia's changing climate, some parts of the country are expected to spend more time in drought. Alongside warmer temperatures, these droughts may be more intense. Use our website to find out about drought in your area.
All right, so as you can see, global global warming can cause a cascade effect, which can cause changes in weather patterns. So, for instance, an area that is now receiving less precipitation might go through a drought, which can have some devastating effects. We're going to talk about some other major weather changes that can occur due to global warming and this cascade effect. So, why is it that things like droughts and extreme storms and flooding might be caused by the warming of the earth? Well, go back to what we talked about in the previous lesson. Okay, we talked about in previous lessons we had talked about ocean currents. We talked about how wind and how air moves in the atmosphere. Okay, this all had to do with hot and cold. Correct? So things move it, so hot air and hot water moving to where it's cooler, and then when it warms back up, and then when it's cool, moving to where it's warmer, and having this flow, right, from one area to the other, right? Well, this flow also causes a even heating of the planet. Okay, so a lot of different areas are warmer because they have warm water flowing over there. If we look at England compared to Buffalo, right, it's a lot farther north on the planet than we are. However, they have similar types of temperatures as we do, right? They are constantly being bombarded by warm ocean currents that are flowing up north, right, through the Atlantic Ocean. So just that causes that area to feel warmer. Okay, there are similar places in Europe that are on, just as far north from the equator as Buffalo, New York, but are a lot warmer. Okay, air currents, ocean currents. Where is the warm air moving? Where is the cold air moving? Okay, now when we start to increase the temperature of the Earth, we're going to affect the way that these things move. We're going to affect the way the air moves. We're going to affect the way the water moves, and that can cause some extreme, different types of weather, and some extreme cases of weather that most places aren't used to. The next thing we're going to look at are some extreme cases of some storms, where these places usually do receive storms, but these storms that they've been receiving in recent times are much more dramatic than they are used to.
Coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island, and as you heard, one official saying the island is destroyed. Maria is the first Category 4 to hit there in nearly a century. 150-mile-an-hour winds ripping buildings apart, knocking out power everywhere. All of the electricity is out tonight. People ordered to stay inside until at least tomorrow amid fears of more massive flooding to come. And the satellite image tonight showing Maria's massive size, dwarfing the island, no part of it was spared. ABC's Victor Akendo leading us off from San Juan tonight.
Tonight, Maria's direct hit, devastating Puerto Rico. The first Category 4 storm to strike Puerto Rico in 85 years, slamming ashore around sunrise.
We are back here on the northern side of San Juan here. I can only imagine what went down when this thing made landfall in the southeast corner of this island. Obviously, the eye getting closer and closer to us, that eye wall now scraping the northern beaches here.
Roofs peeled from buildings, debris flying. Structures collapsing. Up to 30 inches of rain in some areas, engulfing whole neighborhoods. Michelle Torres using everything she can to keep the water out.
The wind howls and screeches, the doors rattle.
We are outside of San Juan in the town of Guaynabo. It was hit very hard. A lot of destruction to homes, down trees and power lines as well. And now they're dealing with this, flooding in every direction. The emergency management director saying the entire island is destroyed. Many of these homes not built to withstand any hurricane, let alone a Category 4.
But the hurricane came and took my house.
Is it all wind damage? Is that what happened here?
Wind damage.
Hospitals damaged, running on generator power. We're standing on one of the busiest thoroughfares in all of San Juan, Puerto Rico, the John F. Kennedy Expressway. Not a single car in sight. We're the only ones out here. Emergency management now confirms 100% of Puerto Rico now without power. Everywhere you look, down power lines, like these, which stretch right across the expressway. 12,000 people heeding the call to get to shelters, including our hotel's ballroom. Evacuees moved off this arena floor due to safety concerns. The howling wind piercing the darkness. Terrified residents singing about strength during trying times to ease the fear. David, you can see the damage right here behind me. This is what so many streets across San Juan look like tonight. Officials saying many areas will be uninhabitable for weeks, maybe even months. They're urging people to shelter in place. They've issued a curfew, and the governor now saying he is launching search and rescue teams as we speak. David?
Victor Oquendo leading us off from San Juan. Victor, thank you.
So as you all know, there have been some major debilitating storms, okay, that have occurred in recent years that have been way worse than they have been in the past. A lot of people have been witness to this firsthand, and it is extremely scary, and it's my hopes that, you know, we can do something to try to counteract this. And that kind of leads us into the next part of this lesson, but there's one more that I would like to talk about before we continue there. Looking at rising ocean temperatures cause coral bleaching when vital algae die off. Okay, so I have a video that explains exactly how this works. It's a short little one, but I saw this firsthand when I was in Hawaii in 2009. I was married, and for our honeymoon, we went to Hawaii, and I got to do some scuba diving. I went to the touristy place, and then we also took a boat off the shore of Kauai, which is a smaller island, and we got to do some snorkeling around there. And I saw some, I saw dolphins and sharks and sea turtles, but it was really hard to see the coral. And I realized that there was just no color to it. It was grayed and white, and it just didn't look healthy. It didn't look like how it's supposed to be. When ocean temperatures increase, the microbiome that keeps the oceans healthy, the algae that's involved, they can become disturbed, they can die off, and that can have tremendous cascading effects on that environment. All right, so let's take a look.
What is coral bleaching? The corals that make up reefs around the world may look like one giant organism, but they're actually an ecosystem with many small creatures working together. Thousands of tiny jellyfish-like animals called polyps connect together to form colonies. These colonies host algae, which provide corals with food, as well as their vivid color, through the process of photosynthesis. A combination of global warming, water pollution, and other environmental disturbances can stress corals, leading them to expel the tiny algae that they need to survive. The process, called bleaching, leaves only a white skeleton, where before there were vibrant colors. Bleached corals aren't necessarily dead. Restoring cool water temperatures or removing pollutants can help fragile corals recover. But without improving conditions, they essentially die. Why should you care about coral bleaching? About 25% of marine life depends on the habitat created by coral reefs. More than 500 million people worldwide rely on reefs for food, tourism, employment, even protection from extreme weather events. And nearly $30 billion in estimated reef value is at stake. Global bleaching events, once a rarity, are happening more often and with greater intensity. We're currently in what scientists say is the worst bleaching event on record, and it could last into next year. Unless we do something soon, coral reefs could go from the cradle of marine life to its grave.
All right, ladies and gentlemen, I've moved on to the next page. All right, so this is page, 412 and 413. We've already gone a lot longer than we normally do. I have one more short video I would like to show you, so I'm going to kind of move through this a little bit faster. All right, so we're dealing with climate change. So what are some things we can do? All right, so first things we can look for alternative energy. All right, so different ways of gaining energy that do not create emissions like carbon dioxide, these greenhouse gases that are causing the issue of global warming. Okay, so alternative energy, we can use things that are instead of using things that are non-renewable, like oil, gasoline, coal, we can use more renewable energy sources. All right, things like wind energy, like the windmills that you would see driving down Route 5, right, just outside Buffalo. If you went to the Niagara Falls trip last year, you were able to learn about the hydroelectric power, right? So the amount of power that's used by the actual flow of the water, right, previously to dropping over the falls, right? They take that water pushes turbines. The turbines are full of wires and magnets, and if you move magnets and wires together, all right, so if you move, basically, and now I'm going to do a quick little physics lesson here. So basically, if you take a magnet and you're running it the correct way over wire, you can actually form an electric current within that wire. So forming electricity from movement, okay? So taking the movement of the water to move magnets and wires around each other in a way that creates an electric current in those wires, and then that current can be stored or sent to different areas, okay? When we're talking about energy efficient technologies down here, all right, so this is just basically taking what we already have and making it work better, all right? Making it more efficient, having it require less energy to do the same job, okay? And you might see certain stickers on appliances like an air conditioner, a hot water tank, a washer or a dryer, a refrigerator, and it might tell you what the energy cost is for that particular appliance. The lower the number, the less energy you're using to run it. All right, so the less it costs, the less energy that you are using to run that appliance. So it's actually more efficient to have a lower cost. Okay, so there's plus side on both of that. Both, you know, it's good for your money and it's good for the environment. Engineering new solutions. All right, so are there ways to reduce carbon emissions that we already have? I'm going to show you a quick video on something that's actually being worked on, and something that in the future may actually help to reduce the amount of carbon emissions we already have in our atmosphere. So let's take a look.
Trees absorb carbon dioxide, but they release it during the night and when they decompose. So Professor Klaus Lackner and engineer Alan Wright have been designing a tree which could be more efficient than the real thing. It was here at Biosphere 2 in our...
Now I'm going to stop right there. I don't think that we should be replacing real trees with fake trees, okay? I just feel like maybe if we add these, we can help, reduce the problem that we already have. The real thing's probably a lot better because A, these are not going to give any habitats back to the organisms that originally were in those trees that maybe were cut down, okay? So planting more trees is always a really good thing to do. However, this may help us in the overall emissions fight.
Arizona, that the idea was first conceived. Biosphere 2 was the largest completely airtight artificial ecosystem ever built, the perfect place to study how changes in carbon dioxide would affect the planet. After working on several prototypes, Klaus and Alan now think they might have finally cracked it. This was an early design, more like a cabinet than a tree. Inside, a plastic that absorbs CO2.
These plastics are ion exchange resins, which are commonly used in water preparation. If you desalinate water or make deionized water, this is the kind of stuff you would use. You can buy it commercially in large quantities.
At first, they used chemicals to wash the CO2 out of the plastic so it could be reused. But this needed too much energy to be viable. Then they made a discovery that was quite simple.
So remember, in order to make stuff work, you need energy. And you want to know where that energy comes from, okay? So if you're using electricity to power your equipment, and that electricity is coming from something that's causing CO2 emissions, then you're not really helping the problem, right? So something like, for instance, that's lower emissions, like air or using water, right, to like we have at Niagara Falls or wind turbines, that might be something a little bit better.
It happened after they'd set up a basic experiment using nothing more than an airtight bell jar hooked up to a carbon dioxide monitor. An experiment they repeated for me.
Here on top you see the plastic material which absorbs the CO2. It has been wrapped in thin strips around the frame.
The level of CO2 in the bell jar starts at 386, today's atmospheric levels. As expected, the plastic immediately absorbs it. So the levels of CO2 in here are really low, round about 140. Okay? But what they do next, they feel is the real breakthrough, and so simple. They dump the plastic in water.
And we'll just put it back in there. So we close it again. Now the air inside cannot escape.
Back in the bell jar, the wet plastic immediately starts to release the absorbed CO2. Okay, and the levels are already going up.
Yes, so we're going to see it's beginning to trend up, and it will pick up over time as the CO2 is given off by that material.
So, just by making it wet, it's now releasing the CO2 that was previously trapped.
Yes, when it's wet, it doesn't want the CO2, so it pushes it off.
It's as simple as that.
It's as simple as that. It's amazing.
It is, and then you can dry it out again.
And when it dries out again, it will grab more CO2. We'll do this over and over and over and over again. And you can literally do this hundreds and hundreds of times.
Having ensured that rainfall will not release the CO2, Alan and Klaus are now building a full-scale artificial tree. When finished, it will have a central drum with panels of the special plastic and a humidity control system. By altering the moisture levels, it will absorb and then release the CO2 for storage. This process requires no chemicals, only a very small amount of energy, and a water supply.
The vision of the future for these kind of artificial trees is that they can capture the carbon dioxide nobody else can capture. That's their advantage, that is their strength.
They estimate that a single tree will absorb about a ton of CO2 a day, about 75 cars worth. 60 million trees could potentially absorb all the CO2 we currently emit. And that's not all.
That is a lot of trees, though. That's a lot of fake trees.
This is one of the few options available to actually go back and reduce the carbon dioxide level in the atmosphere from the level we are already at or will be in 50 years from now, back down to where it is safe.
All this absorbed carbon dioxide would of course need to be put somewhere. But that's where other new technologies come in, like the geological storage of CO2.
That was a question I had, is where's this carbon going to be put? Where it's just not going to be re-released to where it shouldn't be. But
that's being tested in Utah. And because CO2 levels are the same around the planet, a great forest of artificial trees could be placed right on top of storage sites, so the CO2 wouldn't have to be transported.
But where do you put it from the storage site? That's my question. But I mean, it's a good start. I don't think we're ever going to make as many trees as we need to solve the entire issue. But it's a good start. It's a good start. There are some problems, but with any new technology, there's problems, and you got to start somewhere, right? All right. The last thing I want to leave you with was this super lengthy video. Role of government. All right. So the government has issued different legislation over time to help combat this issue of rising global temperature, climate change, issues with emissions. If you look at just, for instance, just a car, there is an emissions check that has to be done during its inspection. All right, that's all part of this. All right, so that's a state mandated thing. New York State says your car has to meet these certain emissions. Like there's certain requirements that need to happen. Like you have to have certain components on your exhaust in order for you to pass inspection. That's just the way it is. But the government does this legislation in order to help combat, right, these greenhouse gas emissions. Okay, so writing to your legislators and explaining to them issues, like I remember talking with our Global Scholars kids this year about all the emission issues and air quality problems over on the west side by the Peace Bridge. I mean, there's cars constantly just sitting on that bridge with their engines idling, just releasing CO2 in plumes, right, on a daily basis, just massive quantities. And the effect that air pollution is having on that area of the city, I mean, it's immense. That is something that you can write to your local government about, and your local government can then fight, statewide and nationwide in order to help make change. These are things that everyday people can do in order to help combat problems that we are facing with the environment or anything else. All right, I'm done. I've said enough. We've seen enough. I think we're good. Try to make these not so long next time. So if you could please make sure that you get your assignment completed on the following pages and upload it under this video, that would be great. I hope you have a great day and a great rest of your week. Please, questions, comments, concerns, let me know. That's what I'm here for. All right, take care, everybody.